good morning. Welcome back to the mathematical concept and its application in chemistry. The mathematical concept and its applications in chemistry. This is the chemical equation and the rate expression of the chemical reaction, where K is the rate constant of the reaction, a general form. We can have the expression for the rate constant or a mathematical definition for the rate constant. If the reaction is simple and the order has a lower value, the mathematical expression will be simple and the derivation as well. If the reaction is complex and the order has higher value and fractional value, the expression for the rate constant will be a complicated and the derivation also a complicated. Now let us go for derivation of the expression for rate constant of simple reaction for lower order. I am taking all together the zero order, expression for zero order, first order and second order. Consider a simple reaction. The simple reaction is just like one reacting system, one reactant. System of one reactant, A gives rise to a product. Simple reaction. For these things, derivations are easy. That is why we have second PUC syllabus is this. The rate expression for this reaction is rate of reaction, its rate constant into A to the power of n, where n is the order of the reaction, A is the concentration of the reactant. Let us commence the reaction. When you commence the reaction, reaction begins with a change in the concentration of A and change in the rate of reaction every time, where K and N remains constant or fixed values. So let us say that at time t equals 0, commencement of reaction, time equals 0. When you commence studying the reaction at the time t equals 0, the concentration, let us call this concentration of the reactant as small a. And as well as in some books you are using that, some books are using the symbol small a. This is the initial concentration of the reactant at the commencement. When you refer literature, in some other books, we have symbols like this. Don't get it confused. You can use any one. The initial concentration symbol is A naught, capital A naught. This is concentration term. Small a are this. After some time, reaction commences, concentration decreases, rate also decreases. After some instant, let us say t equals t, after some time t, concentration, let us say concentration of A is not as A, it is A minus x. A minus x means x concentration of A has changed into product. Here disappear x, it means disappearance of concentration of A after time t. Remaining is A minus x. So every time we say remaining concentration and the rate. So concentration of A after time t equals A minus x. In some other books, the symbols they use A capital simply. Without square bracket say concentration. This is A symbol. A minus x or A. What is x in terms of A? A naught minus A. How much concentration change? Initial concentration is this. At that constant after time t, this is concentration remaining. This concentration has changed. In some other books, they are using these symbols. So this x is change in concentration of A in that time, in that period of time. Then at that time, what is the rate of reaction? dx by dt. What does it mean? Instantaneous rate of reaction. Rate of reaction is instantaneous. At that time, rate of reaction is dx by dt because they are derivative using. So differential function is the one we use to define instantaneous rate of reaction, rate of change of concentration with time. This is the equation in general. Let us write this expression for zero order, first order and second order, same equation. That is one. For a derivation of the expression for zero order, the equation takes the form rate of reaction is equal to K into concentration of A to the power of 0 order. For first order, rate of, if it is first order reaction, this is the equation takes R equals K into concentration of reactant to the power of 1. If the reaction is second order, we will take this form rate of reaction, rate constant, this is second order. Let us write the values of this and this at that instant. What is the instant? Concentration of A. What is concentration of A? At that instant, after time t, A minus x. What is the rate? dx by dt. That is exponential power same now. Concentration, exponential power same. For first order, so concentration of A. dx by dt, rate of reaction. Substitute for this and this. In this equation for second order. R equals this, A equals concentration is A minus x. But exponential is 2 here. Now the differential equation, you have to separate them into separate same functions on one side. That is variables and separables and variables and separables, differentiation. These are differential equations. Okay, we have taken these are differential equations for zero order, first order and second order. Then let us separate them. Functions of, that is same functions, that is x functions on the same side. See, a to the power of a minus x to the power of 0 is 1. Anything to the power is 1 not, remains k. So rewrite this as dx equals x on one time, x on one side, t on other side. Writing that differential equation here, taking x on the same side, this is x function of x, dx by a minus x equals k into the term t on the other side, two variables, t is variable, x is variable. So same on one side, on the other side other. You rewrite this also differential equation as x term on one side, remaining t on the other side. Now we have these differential equations. We go for integral expression. These are differential expression. So for a finite values, we go for integral expression. Recall the process of integration. So we have differential equations. Now requires conversion of differential equation into integral equation. Integration, the concept is integration, the subject integration, recall, and also some standard formula of integration. So for integration, you have to do the integration of what is left hand side, integration to right hand side, integration of function x with the integration of function t. So integral sign, this case constant outside the integral. So this function is variable. So this integral is a definite integrals carrying values now, initial value and final value. At one state it is 0, other state is x, 0 and t. This is called definite integrals. Integrals are two types, definite and indefinite. Here definite India, all these are definite integrals. What does it mean? The t value is varying from 0 to t, that is changing time from commencement of reaction to time t. At commencement, what is the value of x? 0. After time t, what is the x? X equals x, changing concentration x. That is why x is changing from 0 to t is changing from 0 to t. Right? The same, what is the integral? Integral of the function, integral of this function is k into integral of this. Same limits because x, yes. Integral of this. Here also, integral of the function, the same limits. Let us go for integration and apply the limits. That is the process of integration. What is integration of dx? Yes. Why? Integration is the reverse operation of differentiation. What is differentiation of x? Dx. What is integration of dx? Yes. So what is integration of dt? Just like this, t. What is derivative of t? dt. So integration of dx is x, integration of dt is t. And limits after integration, you show the limits, lower limit, upper limit, lower limit, upper. Then apply what is a function with x equals 0 minus function with x equals 0. That is x equals x minus x equals 0, x minus 0. K into t minus 0. Simplify. This is x, this is k into t. What is k? X by t. That is the expression for the zero order reaction. And in some books, a symbol, not symbol x is not used. We have used these symbols. What is x? A naught minus a. That is replace a by this, a naught minus a. You can write any other like this, either this equation. Some books are given now. This is the equation with these symbols. Don't confuse it. This is the equation with this symbol. The same equation is this. Read it. See, rearrangement. That is into and a equals this. Because most of you get confused that different approaches, but ending is same. That is what I am saying now. This is a rate expression for this, either in this time or this time, with these symbols or these symbols. Rate expression for zero order reaction. Let us go for integration of this function. There is a function, function is here. This function, look at the functions. There are standard integral formulas for different functions. First see that what is the type of function? That is 1 by a minus x. A minus x, of course, algebraic function. A minus x is a function, right? Fx. Function of x overall. So 1 over f of x, 1 over the function into dx, integral of this standard formula, recall that this is logarithm, natural logarithm of fx divided by derivative of fx. That is a function of fx. So integration of this is logarithm of this function divided by derivative of this function. Logarithm of this function divided by derivative of this function. So when you do so, what we get now? What is this? Logarithm of a minus x. 1 over a, 1 by a minus x is logarithm of a minus, same thing you apply. And derivative of a minus x. Derivative means the differentiation of a is 0 minus differentiation derivative of x with respect to is 1. This is constant here, initial concentration. So minus 1. Derivative of a minus x is minus 1. So different, what is that? Integration is over. Limits, apply the limits. And right hand side, integration of dt is t, apply the limits. Here minus of this function. Now with the limits, the function is minus of this. What is that? The function with x equals 0. The function with x equals 0. First function is minus logarithm of a minus x. Minus of minus plus logarithm of a, x becomes 0. And a, this is my logarithm functions plus and minus. It becomes, what is that? Logarithm of, what is that? Ratio of a by a minus x equals k into t. Right. So k is 1 by t into logarithm of a by a minus x. This log is a natural log, that is logarithm to the base e. Mathematics very important. So when you convert this logarithm to the base e into logarithm to the base 10, this is logarithm to the base 10 carrying 10. The difference is 2.303. Multiply this 2.303 with this log, this is natural log. So therefore, when you replace by logarithm to the base 10 into this logarithm of the same thing, that is rate constant for the expression, expression for the rate constant of first order reaction. K equals 2.303 into divided by t into log of a by a minus x. In other books, you can replace the symbol by this. What is the initial concept? A naught What is A minus x? A. Concentration after time t. What is concentration after time t? A minus x. So either this equation or this equation. No difference, symbols are difference. Don't get it confused. Let us go for integration of this function. Look at the function. What type of function is this? It is not simply a minus x to the power of 1. Here a minus x to the power of 2. We can rewrite this expression, rearrange this, take it to numerator. Exponent plus becomes minus 2. A minus x to the power of minus 2 into dx. The function with an exponent. So what is the integral standard formula? We have different standard formula for different functions integration. There are a set of formulas are there. Recall the formulas, then only we can follow what is that integration, solving integral problems. This is of the function, integration of the function, because a minus x is function of x. F of x to the power of n into dx. Function to the power of exponent. Integration of this function with respect to x is, what is that? F of x to the power of n plus 1 divided by n plus 1. It is the reverse of differentiation. So to the power of n plus 1 divided by n plus 1 divided by derivative of the function. Standard formula of integration for this. So this function is of this type. So f of x is a minus x, n is minus 2 dx. So this is of this form. Apply this formula. So what is the formula here? I am doing integration. So f of x to the power of n plus 1 means, that is f of x to the power of minus 2 plus 1 minus 1 divided by n plus 1 means minus 1. Again this divided by f dash x, derivative of a minus x is minus 1. Already told you. So derivative of a minus x is minus 1. So the integration is over, limits are applied. Integration is over, limits are applied. Apply, just have rearrangement, minus into minus plus, same thing this. Simplify. Apply the limits. The function with x equals 0 minus of the same function with x equals 0. Minus of lower limit a minus x. A minus 0 1 over a equals k into t at. So what is the final expression? K equals 1 by t into 1 over a minus x into 1 by a. Expression for the rate constant for the second order in terms of other notations. This is a refer book now. In some literature we get this rate here because most of you get confused. But maybe symbols they use now. Approaches are different, but final end is the same. Expression for rate constant of second order reaction. Mathematical definition for second order reaction. Mathematical definition of rate constant for first order reaction. Mathematical definition for rate constant of zero order. These are all together. All of them are taken together and solved it. This is why. So just remember that you apply the same concept. What is that? Integration, standard integration for all this reaction. This is also a simple reaction, and the orders are also simple. So easy for derivation. When the order is lower value, reaction is simpler. Easy for derivation, and the expressions are also simpler. If the complex reaction becomes complex, then you see that the order is also a complex, maybe a higher order or a fractional value. Then expression for rate constant is what is that? You can derive it, but the process of derivation is complicated, and end of derivation also, the formula is also a complex formula. Complex formula. So as per the syllabus we have these derivations. Remember this and this and this for solving problems, and also deriving some more concept from this. Let us see in the next class. Thank you very much.